Okay, so you're looking at Chapter 3 about angles and triangles. We're at the Steam video talking about honeycombs. And you see the sum of the... Number one, this is number one on the Steam video questions. What is the sum of the interior angle measures of the tiling made from equilateral triangles outlined in the yellow below? So when you're looking at this, we're looking at the yellow lines, and we need to figure out the sum of these interior angles. Okay, let me grab my little marker here. So let's look at, we know that one of these little triangles in here, each of the angles is what? No, each angle. 60. So if I look at this point on this weird heart, how many angles are in that point? 2, right? These two are in there, so then that would be 120, right? 60 and 60. So how many angles on this funky heart are there that have 2 angles? Let's count them. We have 1, 2, 3. This one has way more, so we're going to skip that one. 4, 5, 6, 7, 8. So we have 8 points on here that are 120. So write that down. 8 times 120 so far. Okay? Then we have this one point here in the middle that has a lot of triangle angles added to it. Count it with me. We have 1, 2, 3, 4, 5. Does that make sense? Oh, you can just put this in your journal. Oh, did you put your journals away? Piece of paper's fine. I'll wait just a second for you to get paper. So when you're looking at this pointed of the heart right here, how many triangles are touching it? Just the point. We have 1 here, 1 here, 1 here, 1 here, and 1 here. How many all together? Touching this point of the heart. How many triangle points are touching it? 5. So 5, what are the angle measures of each of these points? 1 point is 60. So what's 5 times 60? So those are the two numbers. We have 8 times 120 and 5 times 60. Find my whiteboard real quick. Eight times 120. 8 times 120 was 960?
Yes, ma'am.
Okay, and then that was for the 8 different points on that heart that had 2 angles. And then we have 5 times 60 because those 5 triangle points met at the heart. What's 5 times 60?
300.
Okay, and then you're going to add those up. 960 plus 300 is? Did you say 12? 1260.
Yeah.
So all of the interior angles of the yellow line, all these angles, added up equal 1260, 1,260. So go ahead and type that in. Does that make sense? Where it gets wonky is this weird point in the heart, because you don't think of that as an interior angle because it's pointed as concave. But you have to count all the little points that are touching it. Any questions on that one? Okay. All right, let's look at number 2. This one's a little trickier. Are you ready?
Yes.
All right, the cells in a honeycomb, so this is one honeycomb, use a tiling pattern of a regular hexagon, as you can see here. The side length is 4. It's telling you the cell is 10 millimeters deep. So if I were to turn this facing upward, it's like a tube of honey. Okay, you can't just do 4 times 10 because we need to find the surface area of the hexagon first. Or not the surface area, the area of the hexagon first. So, does anybody know the area for hexagon formula? No, that's not one y'all would have memorized. So you are allowed to look that up. I will show you what it is. So this is the area of a hexagon. Okay, so this is the formula that none of you have ever memorized, and that is totally okay. So you're going to use this formula to solve. What we do know is the side length, right? What's the side length of our hexagon? 4. So where the A is, you're going to put a 4. So 4 squared is 4 times 4? 16. Then you're going to do 3 times the square root of 3. You can do this on your calculator and divide it by 2. Multiply that times 16. You can do it on a calculator, or you can come to this nifty little website and put A where the 4 is, 4 where the A is, and it tells you the answer down here. 41.56. Okay, now we're going to round to a whole number. 41.56 rounds to what whole number? 42. So the area of this hexagon is 42. So the area of this is 42. How deep is this hexagon? 10. So we're going to do 42 times 10 is 420. You are correct.
Yay!
Okay, so this would be 420 cubic millimeters of honey. So when you explain it, I would type things like, not the teacher told me, no thank you, is use the formula for a hexagon. I use the formula for a hexagon, and I would write the formula down in there. There's the formula.
No thank you. Okay.
And multiplied the area of the hexagon times the depth, and got 420.
The square root of 3, right? Yes. That's the square root.
All right, chapter exploration. When an object is transverse, it is lying or extending across something. In the drawing, the fallen tree lying across the railroad track is transverse. Okay, you should have... Oh, you haven't had the lesson yet. So this just means that you have these 2 train tracks that are parallel lines, and the transversal lies across the parallel lines. All right. Do you have to do all this? Okay, I just went over that, called the transversal. How many angles are formed by parallel lines along the transversal? So you count each little section. So 1, 2, 3, 4. Oh, I could use my little highlighter. So 1, 2, 3, 4. And then over here, 1, 2, 3, 4. So you should get 8 lines, or 8 angles that are created. 8. Not you 8. 8. All right, to label each angle, you just label 1, 2, 3, 4. I don't know that it matters which one goes where. There, now they are all labeled. Which of these angles have equal measures, and explain your reasoning. So when you're looking at angles, certain angles have corresponding locations. So if you look at angle 1's location, which is right here, it is in the same location as this angle on the other parallel line, but where the transversal hits. So those 2 angles are going to have the same measurement. So then you would say angles 1 and 5 have the same measurement. And you could say that for any of these other ones that are in the same spot of the transversal. So angles 3 and 7 would be the same. Angles 2 and 6, and then angles 4 and 8 would all be corresponding or having the same measurement. Okay? All right. Next. Why can't I hit next? The other thing you can look at is where they form an X. Let me get my marker. So if I have two parallel lines and I have a transversal going across, you see right here it forms an X. That's called vertical angles. So if you ever have where it forms an X, the angles that are directly across from each other forming that X are called vertical angles, and they will always be congruent. So you can also talk about vertical angles. I don't know why it won't let me hit next. All right, I'm just going to show you the chapter exploration through here. I just pulled up a page. Let me see if I can zoom in here. There we go.
Thank you.
So we're going to look at lines A and B, and we're going to decide whether these lines are parallel and explain my reasoning. So you're doing this on paper, I'm assuming. So if I were to compare line A and B and draw these lines longer. Woo, that's a terrible line. Let me see if I hold shift if it does better. Nope. Alright, so on a piece of paper I would do this with a ruler, but if you're drawing a longer version of this line and then a longer version of this line, you'll notice that at some point these two lines are going to intersect. So when two lines intersect, then they are not parallel. So for A, you would say these are not parallel because the two lines will eventually intersect. So then for B, it says draw a line C that intersects both line A and B. What do you notice about the measures of the angles? So if I draw a line across, you'll notice that these angles are not necessarily going to be the same. In parallel lines, they would be the same. But because this line A is at a different angle than line B, then this angle and this angle are going to have different angles. One thing, let's see here. Draw a line C that intersects both A and B. Now, vertical angles would still be considered congruent. So if that's a terrible line. If I draw a line here, then you will notice that this angle and this angle are still going to be the same, whereas this angle and this angle would still be the same because they are considered vertical angles. So that still does hold true. Okay? Line, let's see, let's look at C. Hold on, I need to... Alright, rotate line A or line B until the angles created by the intersection of the line and C are congruent to the angles. What do you notice about line A and B? So what they're asking you to do is to redraw these so that A and B have the same angles on the transversal. So if I have this transversal, I have an angle here and an angle here. They want you to change the angle of one of these lines so that all the angles that are corresponding would be congruent. Effectively, what that does is makes these lines A and B parallel. So that would be your answer. Lines A and B would then become parallel. Okay, so that's for C. Line A and B would become parallel. Okay, and then for D, rotate line C to create different angle measures. Are the angles that were congruent still congruent? Alright, so they're again talking about the transversal. So if I cut my transversal this direction, is this angle still considered vertical to this angle? Yes, they still form that X, don't they? So then the angles, even if the transversal changes the angle, pretend that's a straight line, your vertical angles will always be congruent. So that's all they're asking there. Yes, the vertical angles would still be considered congruent. So that would be for D. Yes, vertical angles are always congruent. And then E, make a conjecture about the two measures of the angles created when a line intersects two parallel lines. So that's what happens whenever we have this line and this line that are both parallel. So you've changed, let's just say you've changed B to be more in line with A. So you have these two lines like train tracks that are parallel. And if I cut them by a transversal, then this angle and this angle are going to be the same. This angle and this angle are going to be the same measurement. This angle and this angle, and then that angle and that angle. So it makes all these angles corresponding to the other parts congruent. So that's all they want you to figure out. Make a conjecture about the measure of the angles. Then the congruent angles, let's see, how would you say that? The corresponding angles would become congruent. All right, I hope that helps. It's kind of a, when you don't have geometry software, it's kind of a harder exploration to do. I did do the one on the computer already for you, so that should have helped. And then you go into the lesson, which explains all of this stuff. You just figured it out. All right. Let me know if you have questions.